Hi guys, welcome back to another episode of Starting with Starling. Let's start by creating the obstacles for our game and also animate them in the in-game screen. Let's get started. Now before we continue, let me tell you that I have a class called Obstacle already created. I have extended it from Starling Sprite and also added an event listener for added to stage event. The project files provided with this episode should already contain this code. Inside the obstacle class, I'll start by defining the following properties for the obstacles. Private, var, underscore type of type integer. This is to tell what type the obstacle is, helicopter, spaceship, etc. Private, var, underscore speed of type integer. This defines the speed of this obstacle. Private, var, underscore distance of type integer. This defines the distance of the obstacle from the hero. Private, var, underscore watchout of type boolean. This is to track if the obstacle is out of the screen and is showing the watchout sign. The next one is private, var, underscore already hit of type boolean. This is to track if the obstacle is hit by hero or not. If it is hit, we'll set this to true and stop further checking for collision. Private, var, underscore position of type string. This is the position of the obstacle on vertical axis, top, middle or bottom. Private, var, obstacle image of type image. This is the artwork for the obstacle. Private, var, obstacle crash image of type image. This is the artwork for crashed obstacle. Private, var, obstacle animation of type movie clip. This is the animation for only one type of obstacle, the helicopter. It's a 2-frame animation. The last one is private, var, watchout animation of type movie clip. This is the animation for the watchout sign. We are done creating the necessary properties for the obstacle class. Let's accept 4 of these properties as parameters in the constructor. Underscore type of type integer, underscore distance of type integer, underscore watchout of type boolean. I'll set it to true by default, and underscore speed of type integer and set it to 0 by default. Now I'll assign these parameters to the properties of the class. This dot underscore type is equal to underscore type. This dot underscore distance is equal to underscore distance. This dot underscore watchout is equal to underscore watchout. And finally, this dot underscore speed is equal to underscore speed. We'll also set the already hit to false, as when the obstacle is created, it is not yet hit by the hero. So underscore already hit is equal to false. Also, we have to set the watchout to true in the constructor, as we'll set this to false once the obstacle comes inside the visible area. Okay, let's call a function inside onAddedToStage method, create obstacle art. And I'll define the function. Inside this, let's initialize the obstacle art image. Obstacle image is equal to new image. We'll extract the asset from the sprite sheet. So assets dot get atlas dot get texture obstacle plus underscore type. Obstacle image dot x is equal to 0 and obstacle image dot y is also equal to 0. and this dot add child obstacle image. We have added the obstacle image, and now in case we need to display an animation for the obstacle instead of just an image like the helicopter, we need to use the obstacle animation variable. Let's initialize it. If underscore type is equal to 4, obstacle animation is equal to new movie clip. We'll get the textures from the sprite sheet. Assets dot get atlas dot get textures obstacle plus underscore type plus underscore 0. I'll also define 10 as the frame rate. At this stage, let's go ahead and import starling.core.starling. The next thing to do for an animation is to add it to the juggler. So starling.juggler.add obstacle animation. Obstacle animation.x is equal to 0. Obstacle animation.y is equal to 0. And this dot add child obstacle animation. Now we are done with the type 4. For the rest of the types, it's going to be obstacle image. So we'll put that in the else part. The image and the animation for the obstacle is done. Let me define the crash image. Once the obstacle hits the hero, we'll show the deformed or damaged obstacle image. So I'll call a function in the onAddedToStage method, create obstacle crash art, and I'll define it. Inside this, let me initialize the image. Obstacle crash image is equal to new image assets dot get atlas dot get texture obstacle plus underscore type underscore crash. We'll set the visibility to false by default. So obstacle crash image dot visible equal to false. This dot add child of obstacle crash image. Let's create a watchout sign now. This appears a couple of seconds before the obstacle is seen on screen. So I'll call another function inside onAddedToStage method, create watchout animation, and define it. Watchout animation is equal to new movie clip assets dot get atlas dot get textures watchout underscore, and the frame rate will be 10. Starling.juggler.add watchout animation. Now let's align the watchout animation to the obstacle image or animation horizontally and place it on the left side of the obstacle. If underscore type is equal to 4, watchout animation dot x is equal to minus watchout animation dot texture dot width. Watchout animation dot y is equal to obstacle animation dot y plus obstacle animation dot texture dot height multiplied by 0.5 minus watchout animation dot texture dot height multiplied by 0.5. Else If it's not an animation, watchout animation dot x will still be minus watchout animation dot texture dot width, and watchout animation dot y is equal to obstacle image dot y plus obstacle image dot texture dot height multiplied by 0.5 minus watchout animation dot texture dot height multiplied by 0.5, and this dot add child watchout animation. Good. By default, the watchout sign is added to the stage and is visible. Once the obstacle comes inside the screen, we need to hide the watchout sign. So I'll define the getter and the setter functions for the underscore watchout boolean variable. Inside the setter function, let's check for a condition to see if watchout animation exists. If watchout animation, inside this, if value passed is true, watchout animation dot visible is equal to true. Else, watchout animation dot visible equal to false. We'll do the same with the underscore already hid property by defining the getter and setter functions. Inside the setter function, I'll check for the value. If value passed is true, then obstacle crash image dot visible equal to true. If the type of the obstacle is for obstacle animation dot visible equal to false, else obstacle image dot visible equal to false. Just before we get out of the obstacle class, let's just blindly add getter and setter methods for the position, speed, and the distance variables. We'll need to access these variables from outside. Let's switch to the in-game class. Now that the obstacle is defined, let's start adding them on screen and animate them. In the previous episode, we defined the on-game tick function with some simple switch cases. First, because we need the obstacles to appear after a certain amount of traveling done by the hero, we need a variable to hold the distance traveled. We'll declare it as a private variable score distance of type integer. We'll use this to track the score as well. We'll reset it to 0 in the initialize function. Next, in the flying case of the onGame tick function, we'll calculate the distance traveled. Score distance plus equal to player speed multiplied by elapsed multiplied by 0.1. Let's put a trace statement. Trace score distance. We'll debug the project. Observe the console. As the hero flies in and switches to the flying state, the distance traveled is calculated. Alright, now to start adding the obstacles. Let's start by defining a variable to keep track of the distance remaining for the next obstacle. We'll call that obstacle gap count. That will be of type integer, and we'll also reset that to 0 in the initialize method. So obstacle gap count is equal to 0. Inside the flying case of the onGame tick function, let's call a function init obstacle. So we'll initialize it and let's define the function. I'll make the process quick to save time. So here I'll check if obstacle gap count is less than 1200, this is the required distance. If he has not yet reached there, obstacle gap count plus equal to player speed multiplied by elapsed. Else, if obstacle gap count is not equal to 0, obstacle gap count is reset to 0 and we'll create a new obstacle by calling create obstacle method, and this method will accept two values, math.random multiplied by 4. This will define what the obstacle type is. The second parameter is the distance after which the obstacle should appear. So we'll pass math.random multiplied by 1000 plus a minimum compulsory distance of 1000. Let me create this function and rename the parameters to type and distance. Now inside the function, I'll create a new object where obstacle of type obstacle, the new class we created, is equal to new obstacle. We need to pass the type, then the distance, then we need to set the watchout to true, then the speed of the obstacle. Let's just set it to 300 for now. I'll set the X position of this new obstacle to stage width. Now here, the obstacle art will remain outside the stage, but the watchout sign will remain inside. That's exactly what we want. We'll also add it to the display list. So this dot add child of obstacle. Okay, one very important thing we need for the game is the constrained area for the hero, obstacles and the food items. We'll use this bounding rectangle often in the game. So let's declare it. Private var game area of type rectangle. Inside the drawGame method, let's define it. Game area is equal to new rectangle. The X will be 0. The Y will be 100. We need some space for the score. The width will be stage dot stage width. The height will be stage dot stage height minus 250. We don't want the hero to come very close to the ground. Now that we have the game area defined, let's define the position property for the obstacles we add. Just like that, I'll make the helicopter fly in the middle. For all the other obstacle types, I'll make them appear either on top or bottom of the game area. So, at the end of the create obstacle method, if the obstacle type is less than or equal to 3, this is not a helicopter. So let's place it on top or bottom. So if math.random is greater than 0.5, that is a 50% chance, obstacle.y is equal to game area dot top, and the obstacle dot position is also set to a string value top. Else, the other 50% chance, obstacle dot y is equal to game area dot bottom minus obstacle dot height, and obstacle dot position is equal to a string value bottom. Now the other else part, where the obstacle is a helicopter and needs to appear somewhere in the middle, obstacle.y is equal to int math.random multiplied by game area.bottom minus obstacle height minus game area.top plus a compulsory addition of game area.top, and obstacle.position is equal to a string value middle. Right, we are done placing the obstacles outside the stage. Let's quickly animate them. Instead of writing event listeners for each obstacle, let's add these obstacles that need to be animated to an array or vector and animate them. So, let me define a variable private var obstacles to animate. This will be of type vector that will contain objects of type obstacle. Inside the initialize method, we'll initialize this vector obstacles to animate is equal to new vector dot obstacle. Next, I'll add the created obstacles into this vector at the end of create obstacle method. When an obstacle is created, it needs to be animated. So obstacles to animate dot push obstacle. Let's define a function that will animate obstacles in this vector. I'll start by calling that in the onGameTick method. Right after the init obstacle method, let's call that animate obstacles and define it. I'll create a temporary variable to track the animation. Var obstacle to track of type obstacle. Okay, inside this, let me run a loop for var I of type uint is equal to 0, I is less than obstacles to animate dot length and I plus plus. Inside this loop, I'll store the vector element in this temporary variable. Obstacle to track is equal to obstacles to animate of I. Now if the distance value of this obstacle is 0, that means there is no more distance the hero needs to travel to see this obstacle on screen. So if obstacle to track dot distance is greater than 0, let's decrement the distance by current distance traveled. That is player speed multiplied by elapsed. Else, let's remove the watchout sign and bring the obstacle into the screen. If obstacle to track dot watchout is equal to true, then obstacle to track dot watchout is set to false, and outside this if condition, obstacle to track dot x is decremented by player speed plus obstacle to track dot speed multiplied by elapsed. Here I didn't want to just move the obstacle by its speed, but add the player speed too. That's because in the actuals, our player or the hero isn't moving at all. So for that obstacle to move in the opposite direction, we need to also take into account the hero's speed. The last and final thing to do is to remove the obstacle objects once they go out of the screen on the left. So if obstacle to track dot x is less than minus obstacle to track dot width or game state is equal to over, that means we want to remove all the obstacles if the hero collides with any one of the obstacles. Obstacles to animate dot splice, the element is I and we need to remove one element. This dot remove child obstacle to track. So we remove it from the display list. Seems a little long, but I think we are done with this task. Let's execute it. So the obstacles get created based on the distance we defined. They animate to the left and also get removed once they go out of the screen. Now keep in mind that this is a very raw code and there are lots of different ways you can optimize the code we wrote today. I am going to dedicate an episode hopefully at the end of this series to contain tips on optimizing the code for better performance. For now, get your game working, and in the next episode, let's define the hit areas of these obstacles and make them collide. Until then, keep coding, subscribe for updates, and all the best. See you!